Hello everyone, welcome back to our cybersecurity deep dive sessions. Today we will see whether our private information is actually private online. Think again. Today we uncover how investigators use open source intelligence to trace hidden digital footprints across the internet. In this video, we will check invisible trails hidden across search engines, images, metadata, usernames, and intelligence graphs. And by the end, you will see the internet very differently. Every action online creates a trace. A search query, a social media post, a cloud document, even a simple profile picture. Most people never notice this because internet feels temporary, but in reality, digital information rarely disappears completely. Think about this. Every website interaction becomes part of a much larger intelligence puzzle. Search engines index public content continuously. Social platforms collect behavioral patterns. Cloud services preserve metadata. And attackers, investigators, and cybersecurity teams all study these trails for completely different reasons. Now imagine this situation. An employee uploads a harmless resume online. Sound harmless, right? But that single file might reveal technologies used inside their company, internal female formats, software versions, or operational workflows. For threat actors, that information becomes reconnaissance. For defenders, it becomes a warning sign. Modern threat hunting teams actively monitor these exposures because passive reconnaissance often happens long before phishing emails or ransomware attacks begin. This is why open source intelligence become much critical part of enterprise cybersecurity. The internet constantly leaks small fragments of intelligence, and when those fragments connect together, the bigger picture becomes surprisingly dangerous. Google is far more than a search engine. In cybersecurity investigations, it becomes an intelligence discovery platform. Most people type simple searches and stop there, but investigators approach search very differently. They understand that search indexing continuously maps public infrastructure across the internet. Think about this. Every publicly accessible document, login page, cloud portal, or achieved web page can potentially appear inside search results. Now imagine a company accidentally exposing internal PDFs or development environments online. The organizations may never notice it, but search engines might already have indexed those resources days earlier. This is where things become dangerous. Threat actors use advanced search refinement techniques to discover exposed information silently before launching phishing campaigns or ransomware operations. Meanwhile, defenders use similar intelligence workflows to monitor attack surfaces and identify accidental exposure. Cached pages add another layer of risk because deleted content sometimes remains searchable long after removal. Security teams now integrate external visibility monitoring into threat intelligence operations because attackers often begin reconnaissance through publicly indexed data first. But here's the interesting part. Organizations usually focus heavily on firewalls and EDR tools while ignore the information already visible to the outside world. And sometimes exposure starts with a single indexed file. Metadata tells stories people never intended to share. Open an image, a document, or a PDF, and hidden information often exists beneath the visible content. Timestamps, device names, GPS coordinates, editing history, usernames, software versions. Most people never see this layer because it operates silently in the background, but investigators pay close attention to it. Think about this. Someone uploads a photograph anonymously online. At first glance, it looks completely harmless, but here's where investigators get surprised. The image metadata may still contain exact location coordinates, camera information, or timestamps relieving when and where the image was created. Suddenly, the investigation changes completely. Digital forensics teams use metadata analysis to reconstruct timelines, identify operational mistakes, and strengthen attribution during cyber investigations. Enterprise environments face similar risks. Employees sharing internal documents externally may unintentionally expose infrastructure details or usernames embedded inside files. Threat actors also understand this problem, which is why sophisticated malware operators frequently attempt to remove metadata traces before publishing stolen information. But operational mistakes still happen constantly. Security teams increasingly sanitize documents automatically before external sharing because metadata leakage can quietly expose sensitive intelligence. Sounds invisible, right? That's exactly why it becomes so powerful during investigations. Username seems insignificant until investigators begin connecting them across platforms. Most people reuse digital identities without realizing how much behavioral information they reveal over time. A gaming alias, a developer profile, a forum account, a social media username. Individually, they appear disconnected, but together they can expose habits, interests, operational patterns, and even real world identities. Think about this. A threat actor uses one alias on a hacking forum years ago. Later, a similar username appears on cryptocurrency platforms, leaked databases, or phishing infrastructure registrations. Sounds coincidental, right? But here's where intelligence analysts become dangerous. Correlation. Investigators map identity pattern across multiple environments and slowly build a much larger picture. Cyber crime groups often fail operational security because humans naturally repeat familiar behavior. Enterprise defenders also monitor username intelligence to identify impersonation campaigns targeting employees or executives. Attackers frequently create fake profiles designed to support phishing operations or social engineering attacks. And this changes everything. Modern cybersecurity investigations are no longer focused only on malware or network traffic. Human behavior itself became an intelligence source. The internet remembers patterns extremely well, and sometimes a reused username becomes the first clue exposing an entire operation. Images contain more intelligence than most people realize. Investigators don't just look at the subject of a photograph, they study everything around it: background subjects, reflections, street layouts, shadows, screens, even weather conditions. Think about this: someone posts a simple office selfie online, harmless, right? But in the background, a whiteboard reveals internal project names, a badge exposes company branding, a monitor reflects leaks infrastructure diagrams. Suddenly, that single image becomes an intelligence goldmine. Reverse image analysis adds another layer. Investigators can trace where images appeared previously, identify reused content, or uncover fake persons operating across multiple platforms. AI security technologies are accelerating this process dramatically. Modern image analysis systems can identify objects, detect manipulation, and correlate visual patterns at enormous scale. And but here's where things become even more complicated. Deepfakes and synthetic media are beginning to blur the line between real and fabricated evidence. Enterprise cybersecurity teams now monitor image based exposure because threat actors increasingly use visual intelligence during reconnaissance. A single photograph can expose physical locations, cloud infrastructure, employee identities, or operational workflows. Most people only see the image itself, investigators see the hidden environment around it. Cyber investigations become much more powerful when relationships become visible. This is exactly why tools like Maltego changed modern threat intelligence workflows. Instead of analyzing isolated data points manually, investigators map entities visually across connected intelligence graphs. Domains connect to IP addresses, usernames connect to organizations, infrastructure connects to phishing campaigns, threat actors connect to malware operations. And suddenly, hidden relationships begin to emerge. Think about this. A ransomware investigation starts with one suspicious domain. Sounds small, right? But here's the interesting part. Correlation engines can reveal linked servers, reused email addresses, overlapping infrastructure, and connected threat actor ecosystems within minutes. What originally looked isolated suddenly becomes part of a much larger campaign. Enterprise system on chip teams increasingly combine security and incident event management alerts, EDR telemetry, and open source intelligence into unified investigate workflows because attackers rarely operate through single indicators anymore. Visualization dramatically improves threat hunting because humans recognize patterns much faster when relationships become visually graphical. This is where investigators get surprised. The real power of intelligence isn't collecting more data, it's understanding how separate pieces connect together. And sometimes one connected node exposes an entire cyber criminal network hiding behind it. Open source intelligence is no longer optional inside enterprise cybersecurity. Modern organizations continuously expose information externally whether they realize it or not. Cloud assets, employee contacts, third party services, public repositories, brand impersonation pages. The attack surface keeps expanding. Think about this. Ransomware groups often perform reconnaissance weeks before deployment. They study exposed systems, leaked credentials, and employee behaviors quietly from the outside first. By the time malware executes internally, the investigations actually began long ago. This is why threat hunting teams now monitor external intelligence continuously. SOC analysts combine SIM data, EDR alerts, phishing indicators, and open source intelligence feeds to identify risks earlier. Zero trust architecture also depends heavily on visibility because identity exposure frequently becomes the first stage of compromise. But here's where things become dangerous. Organizations become often secure internal infrastructure while ignoring external exposure completely. A forgotten cloud bucket, an indexed login portal, an employee sharing sensitive screenshots online, small mistakes create major attack opportunities. AI security systems are helping defenders process this intelligence faster, but attackers are also automating reconnaissance workflows aggressively. The battlefield is changing rapidly, and visibility itself has become one of the most important defensive capabilities in cybersecurity. The future of open source intelligence will look very different from today. Artificial intelligence is already transforming reconnaissance workflows across both offensive and defensive cybersecurity operations. Threat actors now automate phishing research, identity correlation, and infrastructure mapping using AI driven systems capable of processing massive public datasets rapidly. But dependers are evolving too. AI assisted threat hunting platforms now analyze cloud logs, social intelligence, EDR telemetry, and digital exposure indicators in near real time. Think about this. Investigations that once required days of manual correlation may soon happen automatically within seconds. Sounds powerful, right? But the real problem starts here. Deepfake, synthetic identities, and manipulated media are making attribution increasingly difficult. Investigators can no longer trust visual evidence automatically. Meanwhile, quantum computing introduces another long term challenge because further quantum systems cloud potentially impact encrypted intelligence, archives, and secure communications. Enterprise cybersecurity teams are preparing for a world where intelligence moves faster than ever before. Real time monitoring will expand. Automation will dominate investigations, and privacy debates will intensify globally. Here's where things become truly fascinating. The future cyber battlefield may not belong to whoever launches the most attack. It may belong to whoever understands information fast. So, as a summary, open source intelligence has changed cybersecurity forever because information itself become a battlefield. Every search result, image, document, username, cloud service, and social media post contributes to a constantly evolving intelligence ecosystem. Most people never notice how much data they expose publicly, but investigators, threat hunters, and cyber criminals understand the value of correlation extremely well. Think about this. One isolated clue rarely matters. A leaked username alone may seem harmless. A metadata timestamp may appear insignificant. A public image might look completely ordinary, but when investigators connect those fragments together, an entirely different story emerges. And this changes everything. Modern enterprise cybersecurity now depends heavily on external visibility. Organizations monitor phishing infrastructure, ransomware indicators, cloud exposure, impersonation campaigns, and attack surface intelligence continuously become because attackers often begin reconnaissance long before malware execution ever happens. AI security technologies are accelerating both defense and offensive intelligence gathering at incredible speed. At the same time, deepfakes and synthetic identities are making attribution far more difficult than before. The future of cybersecurity will increasingly revolve around intelligence correlation, automation, and visibility. Here's the most important takeaway. In the digital world, information rarely disappears completely. The internet remembers patterns, and people who understand those patterns often control the investigations. If you enjoyed this investigation, subscribe for more deep cybersecurity breakdowns and tell us below what digital traces do you think people expose without realizing it.